Section 2.5 is proving statements about segments and angles. So a proof is a logical statement that uses deductive reasoning. Remember, we had deductive and inductive reasoning. Proofs use deductive reasoning to show that a statement is true. For the most part, we will use the two-column proof. And in a two-column proof, you make one statement at a time until you reach the conclusion. Because they are based on facts, again, you are using deductive reasoning. The reasons used in a proof can include definitions, properties, postulates, and theorems. A theorem is a statement that can be proven. Once you have proven a theorem, you can use that theorem in other proofs. So as we keep going along here, we're going to have more theorems. Again, I don't want you to remember them as Theorem 2.1. You can put that as part of it if you need to. I don't think it is allowing you to, but you just can't tell me, oh, the reason is Theorem 2.1, because again, Theorem 2.1 in this textbook is different than a Theorem 2.1 in another textbook. All right? So let's go ahead and talk about some of these theorems. So the first theorem we've had is Theorem 2.1, which is properties of segment congruence. So segment congruence is reflexive, symmetric, and transitive. Now, we learned all of those yesterday. So remember, for any segment then, what it is saying is line segment AB is congruent to line segment AB. So yesterday we learned that their measures were equal. Now we can state that the segments are equal. Same thing with symmetric. If line segment AB is congruent to line segment CD, then again, I kind of told you we're kind of flipping it. Then we can say that line segment CD is congruent to line segment AB. And then finally, the transitive property, if AB, line segment AB, is congruent to line segment CD, and line segment CD is congruent to line segment EF, then you can say that line segment AB is equal to line segment EF. So remember, what we were talking about kind of yesterday is, remember, I said we could say it if P is equal to Q and Q is equal to R, again, since these two are one right after the other, all right, you can say then that P is congruent to R, all right? And that's a little different from the law of syllogism. Remember, we talked a little bit about that. They don't have to go in order. With the law of syllogism, we could have actually said these two first, all right? But with transitive, it has to be in order. And if you notice, that was segment congruence. If you look, same thing with Theorem 2.2, but we're talking about angles. Reflexive, again, for any angle A. Angle A is congruent to angle A. Again, I know that sounds silly, but I do tell you that is one of the most powerful ones we can use when we talk about proofs. Symmetric, if angle A is congruent to angle B, then we can flip it and say that angle B is congruent to angle A. And then again, if angle A is, let me go ahead and do this again. So if angle A is congruent to angle B and angle B is congruent to angle C, then we can say that angle A is congruent to angle C. So again, just like I showed you the other day, P, and Q and R. All right, so that's what we need to know right there. Now we're going to do 4 proofs actually. The first one, I'm going to kind of put stuff around it for you as we're doing it. And so you can see what a 2-column proof looks like. Well, that's what it looks like. It has 2 columns. One of them is called statements. One of them is called reasons. Okay, we're always given something. Either part of it or all of it will be what you will use at the beginning, and your reason will be given. And then we're going to go from there. All right. what you're trying to prove is always going to be the last statement. Okay, and then sometimes if they have one, you want to copy or draw diagrams. If they don't have one, or if we're doing it out of a textbook or something like that, you should copy or draw diagrams. So copy or draw diagrams. And label given information. So given info or information, I'm just going to shorten it up so we can write more, to help develop proofs. Okay. And we're going to look at that little diagram there in a second, see how it helps us. Okay. Remember what I just said, but we're going to go ahead and rewrite it. So statements. All right, are based on facts. That you know. Or on conclusions from deductive reasoning. Oops. And remember, that can be from postulates, which are statements we assume to be true, or previously proven theorems. Okay. Let me tell you. All right, this one here has 4. Notice how when you're doing it, the right way to do it would be, if you see 4 statements here, number them, and in the other column, number the reasons. I think for the most part, unless I give you a worksheet, most parts it will be given for you. All right, but the number of statements will vary. All right, this one right here only has 4. One of them has 6. 2 of them have 6, and one of them has 7 that we have. I've seen them up to 12 and sometimes even 14. All right, I don't think we'll ever get that far, at least in this class. All right. So remember, our reasons are always going to be reasons will be definitions. Postulates. Again, or previously proven theorems. That allow you to state the corresponding statements. Oh, sorry, I didn't realize I was in the way. Remember, I told you yesterday when we were working on section 2.4, remember we had that middle column there, and I said that one was going away. So as you can see, it is the case. So let's go ahead now and work a little on this proof. All right, so the first one statement is what is given. So AC is equal to AB plus AB. That was given to us. All right, so we know that we have looking for a color I didn't use. We know that this length from here to here is AB. All right, they're telling us that AC is equal to AB plus AB. So what it's kind of telling us is that we have that there, all right? But now again, according to this segment here we can also say that AB plus BC is equal to AC. Now if you think about it, that was from the segment addition postulate. So that is going to be our reason for that one. From chapter 1, remember we did the segment addition postulate. Okay. Now, we have AB plus AB is equal to AB plus BC. All right. So on that one there, if we look at it, this AB and this AB are the same. All right. So again, if you think of P plus Q is equal to Q plus R, then we can kind of get the one by itself. All right. So what did I just say there? I said P, then Q, Q, then R. So which property was that? That was the transitive property. All right. So that was from Theorem 2.1, because Theorem 2.1 talked about segments. But again, you don't have to write all of that. When you drag and drop it, it'll have a lot of that for you. I would allow you, if we were going to write this, I don't want you to have to keep writing the transitive property of equality. I would just let you write the transitive property. Okay, and then remember, we always have to give a reason for the last statement too. And what are we going to do here? Kind of look at what we did. So how do we get from AB plus AB and AB plus BC to AB and BC equal? Well, if you think about it, what we just did there is if I subtracted AB on this side and I subtracted AB on this side, those ones would go away, correct? So what did I just tell you we just did? I said we just would do subtraction. So subtraction property. All right, and that is our last statement. And so we are done. We have done that whole thing. Notice there were 4 statements and 4 reasons. Okay. All right, let's go ahead and so on that one there, just to show it to you, I showed you everything. If you notice on this one here, we kind of did this. I think on some of your homework, you're going to do partial fill in the blanks here and there, and maybe even some like this. So our next one, I actually have here one that has some of the fill in the blanks that you have to do. All right. So on this one right here, we're given that M1 is equal to, so the measure of angle 1 is equal to the measure of angle 3. All right, so again, remember what I told you. The first one is always something that is given. Well, they told us it was given, so you have to tell me here that the measure of angle 1 is equal to the measure of angle 3. And if you notice there, people, they do have a mark here, right? With the little arc there, right? So both of them have a little arc there, so you know that they are equal in measure. Okay. All right. And then the second one tells us that angle EBA, so EBA, that's that one right there, is equal to angle 2 plus angle 3. Well, if you look at it, it is equal to those two. All right. And that is by the angle addition postulate. Okay. Now they're telling us that on 3, they're saying that EBA is equal to the measure of angle 2 plus the measure of angle 1. Well, if you look at it, from what we were given up here, okay, we were told that the measure of angle 1 is equal to the measure of angle 3. So what I just did here was I substituted angle 1 for angle 3. Okay, that's what we did. So on this next one here, the angle of the measure of angle EBA is equal to the measure of angle 1 plus the measure of angle 2. Yep. All right, and what did we do? We just kind of flipped it around, right? That's the commutative property. I kind of think it's almost like the symmetric property, but since we were doing addition, all right, with the other ones, it was of equality. So you're basically doing kind of the same thing there, okay? I just wanted to make it look a little nicer. All right. So now I have that the measure of angle 1 plus the measure of angle 2, again, kind of look at your diagram there. The measure of angle 1 plus the measure of angle 2 actually equals this one here. And what is that one there? That is CBD. All right. So this one up here allowed us to say this one right here. Now we're going to talk about this one right here, because again, that's kind of what we're trying to solve, prove, right? So I can say then that on 5, the measure of angle 1 plus the measure of angle 2 is the measure of angle CBD. All right. I know it's going to take some of you a little while, but that's okay. But again, remember, the last one, no matter what, the first problem is what you're given, right? And then the last statement is always what you're trying to prove. The last statement is what you're always trying to prove. So we are trying to prove, in this case, that the measure of angle EBA is equal to the measure of angle CBD. And again, if you think about it, from the 2 previous statements, that is the transitive property. So let me show you again one more time here. So if P is equal to Q and Q is equal to R, then we can say that P is equal to R. All right, so that's where our Q's were the same here, which they're supposed to be. So that's why we could say for the last statement there, the last reason, is by the transitive property of equality. Okay, all right, 2 down, 2 more to go. All right, and on that one, everything was already marked for us, right? Sometimes it's not going to be marked for us, and we have to mark it, all right? So on this one here, it says given line segment AB and CD bisect each other at point M, and BM is congruent to CM, all right? So they're telling us that BM is congruent to CM, all right? But again, if they bisect each other at point M, you can tell me this, right? Okay, remember the tick marks. They told us A, B, and CD bisect each other. So we can then would say that AM is equal to MB. And the other one would be CM is equal to DM or MD. Either way, I think it says it DM. All right. Notice have those marked. And they're kind of telling us, and so I'm just going to circle these ones for you. They're telling us that BM on this one right here, BM is equal to CM. So they're actually telling us that this one here and this one here are actually equal to each other. I just didn't want to mark them with a tick mark because we already have them and we're going to have to use that. Okay. So they told us, again, I'm going to tell you, sometimes you use all of it, the given. Sometimes you just use the part that lets you see stuff. All right. So the first one is BM. Line segment BM is congruent to line segment CM. That's this part right here, right? And that's given. Now we have that CM is congruent, line segment CM is congruent to line segment DM. Again, I marked those. And what is our reason? Okay, they are what? They're segments and they bisect. So on the second one there, our reason is going to be definition of segment bisector. Okay, now look at our statements again and see if you see a pattern. Let's see if we see it this time. I have P is congruent to Q. Q is congruent to R. So we can say that P is congruent to R. Okay, did I say that right? If P is congruent to Q, Q is congruent to R, then we can say that P is congruent to R. And what property was that? We just talked about it. Transitive property. I should have moved it back to purple, but that's okay. All right. So now we know that the segments are congruent. So if segments are congruent, then we know that their measures are equal. Okay, segments congruent. implies that the measures are equal. And again, how do we know that? By definition of congruent segments. Okay, and now let's see. What do we have? We have AB. So let's see, what do we need? We need AB is equal to AM plus DM. But if we look up here, what we can say, man, I do that a lot. What we can say right now, based on our diagram, we can at least say that those two are, right? So we can state that AB is equal to AM plus BM. And again, look at the statements there that we can use, logical statements. If we look, what has changed? This one right here, AB equals AM. This part here stayed the same. This is what changed. And what did we do? We substituted DM for BM, right? We substituted DM for BM because that's what we were trying to prove. I gotta move that somewhere because I keep hitting that. Okay, so again, I just said substitution. That's our reason. All right, it's a good thing I have the weekend before we do this homework so we can kind of look at this a couple times if you're not understanding it. Okay, so that's it for that one. All right. Again, notice how we're looking at all of the previous ones in order to give us reasons for the next statements. Okay, I could have put, again, substitution property of equality. You'll just be dragging and dropping. Okay, so our last one here. And again, these are ones I just found and kind of cut and pasted them on here so I could give you ones that you were filling in the blanks. I thought that was pretty fair. So our last one here says given angle AEB is a complement of BEC. AEB is a complement of BEC. And what does that mean? All right, what does complement mean? Well, that means that their measures equal 90 degrees. Okay, their measures equal 90 degrees. So we can say that the measure of angle AEB plus the measure of angle BEC is equal to 90 degrees. All right, so here's a little hint for you. Whenever they tell us is or are or something, okay, most usually the reason for the next statement, in this case, the measure of angle AEB is equal to the measure of angle, plus the measure of angle BEC is equal to 90 degrees, is by definition. So they told it is a complement, and we can state that it equals 90 degrees by definition of complementary angles. Okay? So let's look again here. We know that the measure of angle AEC is equal to the measure of angle AEB plus the measure of angle BEC. And how do we know that? Because that is what are we doing? We're taking this angle and we're adding it to that angle there. So we are using the angle addition postulate. Okay. Now we're told that the measure of angle AEC is equal to 90 degrees. All right. So again, let's see the reason why. Hopefully you're seeing it here. Okay. And this time I'm just going to use this. We have if P is equal to Q and Q is equal to R, P is equal to Q and Q is equal to R, then we can say that P is equal to R. And what is our reason there? We should know this by now. Transitive. Very good. Okay. Now, that's about all we can do there. So we have to keep looking. What is our goal? We need to show or prove that the measure of angle AED here is equal to 90 degrees. Well, I just told you this one here, those ones together, which is now AEC, right? I told you that this one plus this one by the angle addition postulate is equal to 90 degrees. So you know that this one here is 90 degrees. Well, we also know that we can say that this angle here and this angle here, they are supplementary. So I can say that the measure angle AED plus the measure angle AEC is equal to 180 degrees. And again, that is by definition of supplementary angles. Now, I want you to look. I'm going to take this, and I'm going to substitute this in for this. That's why it's called the substitution property. So we are going to say that the measure of angle AED plus 90 degrees is equal to 180 degrees. And my last statement, and this time there were 7 of them, so I did tell you they vary. On this one here, is that what we're trying to prove? Yes. Have you noticed that the last statement in all 4 of these proofs is what you're trying to prove? All right. So now how do I get from plus 90 equals 180 to just being able to say it's 90 degrees? Well, I'll do it the old-fashioned way. You subtracted 90 on each side, right? So what did we just do? That was the subtraction property. And again, it would say of equality, but I'm good with just saying subtraction property. All right. Hopefully mull those over on this weekend. Maybe look at the examples in the textbook, ladies and gentlemen. We'll do the homework on Monday. Thank you.